Looks like we are live. Hello and welcome to Mr. Linford's live stream for today, May 18th. What I'm going to do in this live stream is I was thinking about going over the sections that we were reviewing today, section 8.2 and 8.4 if you're following along in the book, but basically the general topics of how to evaluate functions and as well as how to compose given functions. In the morning live stream I went over several problems, several more challenging problems I should say, from last week, the factoring unit. So if you'd like, that video was recorded and posted on the YouTube page, so you can go and check it out. That was 5:18 the AM live stream. This will be 5:18 the PM live stream, and we're not going to do so much factoring in this as much as we're going to just start off in the two sections we are reviewing today. If you have any questions or comments or things you'd like me to go over, please let me know. We got a live chat feature going on this side here. You can go ahead and let me know if there's a problem you'd like me to review, or if there's any questions that you have about the problems that I do cover or the general topics. Please just let me know over in the live chat. Let's go ahead and start with section 8.2. You'll notice I give you two functions here, function g and function h. Remember, we give functions names because we want to know what function are we talking about. If I labeled both of these functions as f, like f of x, and I said, oh, take the function f of x, you'd say, which one? They're both f of x. In either homework, I think I give you like 4 or 5 functions. If I named all of them f of x, you wouldn't know which one I was referencing. So make sure that functions, you understand that their names mean that they are different functions. And when I call a function, I'm indicating use that specific one. So when I say g of negative 2, I mean use the function g. All right, so we're looking at this whole thing here. And when I say g of negative 2, that means take the function g and plug negative 2 in for x. So every time I see an x, I'm plugging in negative 2. The purpose of this is this tells you what to sub in for x. Okay, that tells you I want you to take the function g and tell me what you get when you plug negative 2 in for x. You'll notice that any time I plugged it in, I used parentheses. The reason being, well, one, it helps me to see what was substituted in. Excuse me. But again, like I mentioned in the morning live stream, it's really going to help us when we deal with exponents. Let's take a look at this first operation here. We have negative 2 times negative 2 squared. What should we do to simplify this? Well, hopefully you're referring back to the order of operations, and you're saying, well, we have to do the exponent first before we can multiply the terms. So I need to square negative 2. Negative 2 squared, as I jump pages, negative 2 squared is 4. And then I need to multiply that by negative 2 to get a negative 8. Okay? I applied the exponent first to square negative 2, so I get 4, and then I multiplied it by negative 2 to get negative 8. So let me go ahead and write that down. That's negative 8. 3 and negative 2 is negative 6, and then a negative 7. One thing I want to point out that's special about these parentheses, by writing negative 2 in parentheses and squaring it, I'm indicating to square all of negative 2. That's different than if I did not write it in parentheses. If I just wrote negative 2 and squared, this would get me a negative 4, while this would be a positive 4. The reason is this says apply the exponent first and then apply the negative. Okay? Exponents only affect what they're immediately touching. So, since the exponent's only touching the 2, it's not touching the negative, it means square the 2 and then make it negative. All right? The reason is because we can actually write this, I'll write it down here, as negative 1 times 2 squared. That would be the same thing. Now, here, in the left-hand example, the exponent is touching all of negative 2. It's got the sign and the number with it. So that's why you have to be careful here. Your calculator actually knows this rule. If you typed in parentheses, negative 2 and squared it, you get positive 4. And if you typed negative 2 squared without parentheses, you would actually get a negative 4. So just be careful on that distinction. I know it's obnoxious. I know it's irritating to deal with. but there is that subtle distinction in our notation. And that's why I want us to be very careful so we can use parentheses to help us out. Okay? Using parentheses will help us be very careful with our work. So let's go ahead and combine these values. We get a -8 and a -6. That's -14. And -7, that should be -21 if I'm correct. Yeah. So our answer should be a -21. Now let's go ahead and take a look at h of -7. By the way, this problem was 2 from the advanced practice. And now let's go ahead and do problem 3 from the advanced practice. So in problem 3, we said h of -7. That means take the function h, and every time you see an x in that function, change it to a -7. So we have negative and, oh, here's an x. So I'm going to put -7 in. And I got to square that. Plus 3 times, oh, there's another x. So I'm going to put a -7. The idea here is that, again, anytime you have an x, you sub in -7. Why I write it in parentheses is because that's the whole thing, right? When I say square the x, all right, I mean square all of -7. When I say take 3 times x, I'm saying take 3 and multiply it by all of -7, not just the number or the sign, okay? So that's why I write the thing in parentheses. Let's take a look at this first term, because I think that'll make it a little more obvious how this is helpful. Notice that we have a negative, and then we have to take we have to square the -7. Think back to order of operations. We need to apply the exponent first. Then we can apply the negative. This is like saying we have -1 times all of -7 squared. Okay? Let's apply the exponent. -7 squared is positive 49. And then let's apply the negative to make it -49. That's what's going on here. A lot of people think that this is really, well, -x squared should be a positive x squared. They think, why not, right? This is the same thing. It's not the same thing because this -x is not written in parentheses. What this is saying, this -x here, what it's really saying is to take whatever x is, square it first, and then multiply it by -1. Okay? So that's what we're doing right here. We took what x was, it was -7, and I squared it to get the 49. Once I got that, I multiplied it by -1 to get the -49. So that's my very first term, I should say. So that's a -49, and then let's take 3 times -7, that's -21, and then -9. Hopefully this is making sense to you, and you're seeing how we're really just using order of operations here. And really, the key importance to this is using parentheses to make sure we're organizing our work as best as we can. So let's go ahead and combine some numbers here. -49 and -21. Well, if I add the 1 to it, I get -50, and then 20 more should get me to -70, and then another 9 should get me to -79. I think that's correct. Yeah, we should be good with that. Okay, so that's the idea of evaluating functions. You take whatever function you're being told, right, because they have names. Here was h and here was g. And we're told, okay, take that specific function, and every time you see an x, plug whatever's in parentheses in for that. Substitute it in. Let's go ahead now and try to expand on that by doing the composition of functions. When you see the composition of functions, what I'm asking you to do, instead of plugging a number into a function, I'm asking you to plug a function into a function, excuse me, as I'm losing my voice here. I'm asking you to plug a function into a function. So, let's take a look at this notation. This is read f after g of x. Sometimes it's also read, instead of f after g of x, f of g of x. And all that this is saying to do, and this symbol right here, it looks like it's like I spelled fog or something. This symbol right here is just a tiny like circle. It's not a closed dot. It is not a closed dot like multiplication, okay? It's just a tiny circle, like the degree symbol or just some kind of little open dot. Not a closed dot, but an open one. This is not multiplication. Let me point this out to you. Not multiplication. We are not multiplying polynomials here, okay? We're not multiplying expressions. What we are doing is we're going to plug expressions in for each other. What I mean by that is this. F after g of x means take the function f and plug the function g in for it, okay? This is your inner function. This is your outer function. I guess I can write that down. Outer, as my stylus wants to quit on me. The outer and the, oh gosh, come on. Let's try this a little neater. Inner. Okay? G is the inner, f is the outer. So I'm saying take that whole function f, and I want you to plug in what g is. G is x squared minus 3x plus 7. So every time you see an x in the function f, plug this into it. So here's the function f, 3x minus 5. But wait a minute. Every time there's an x, I have to plug in what g is. X squared minus 3x plus 7. So there I go. I just plugged that in, and of course I have to have a minus 5 to finish it off. But this is the function f where I've plugged g in for x, okay? You can see this is the inner function that was plugged into the outer function. And you can simplify this. Let's go ahead and do that. We have a 3x squared minus 9x plus 21 minus 5, if I go ahead and distribute the 3. And 21 minus 5, that should be a 16. And that would be if we combine the like terms. But there we go. We have our polynomial. This is what you get when you plug g into f. Now let's take a look at problem 2 from the independent practice. F after k. Again, the outer function is f, and the inner function is k. Oh, come on. All right, close enough. All right, the outer function's f, the inner function's k. That means take the function f and plug whatever k is into it. So take the function f, and k is the square root of 3x plus 2. That's what we're plugging into f. All right, so the function f is 3 times, well, the input is x, so the square root of 3x plus 2 minus 5. All I did was I took the function f, 3x minus 5, and every time I saw an x, I plugged this into it. That's all that I'm doing, okay? And this is as far as you can go. This is as much as simplified as possible because you can't take the square root of anything in there. It's the 3x and a 2, so you're pretty much stuck as it is, and this would be your final answer right here. Now let's try the reverse. Let's try k of f of x. This is problem 6 from the independent practice. K now is the outer function, and f is the inner function. So what I'm saying is take the function k, and every time you see an x in that function, replace it with whatever the function f is. So that means take k, and every time you see an x, change it to 3x minus 5. Like literally plug that in for it, substitute it in. So I'm going to take k, which is the square root of 3 times x, and oh, there's an x there, so I'm going to put in 3x minus 5, and then plus 2. There's the function. I took the function 3x plus 2, and where there was that x, right there, I subbed in what f was. I plugged this in to that function, or I plugged this into that x value. You could simplify this if you wanted. It's the square root of 9x minus 15 plus 2 but minus 15 plus 2 is minus 13. And there you go. You should be good with that. So this is the idea of compositions, where you plug a function into another function, okay? It's just a game of substitution. Just like if you would plug a number into a function, right? You'd sub that number in for x. Here, I'm giving you an expression to sub in for x. So every time you see an x, I'm saying plug 3x minus 5 in, or the square root of 3x plus 2. That's it. All you gotta do is kind of cut and paste it in, okay? Let's try a problem from the exit ticket. This is problem 2 from today's exit ticket. Here are two of the given functions, x squared minus 5 and negative 3x. What I'm asking you to do is to evaluate g of h of x. The outer function is g, and the inner function is h. So what I'm saying is, let me get some room here, I'm saying take g and plug into it what h is, negative 3x. So every time you see an x in the function g, plug negative 3x into it. Okay? Plug it right in. Let me try to write that neater. There we go. So here's the function g. It's x squared, so instead of x I'm going to write negative 3x, and I'm supposed to square that and subtract 5. Well, if I wanted to simplify this, I could. Negative 3 squared is positive 9. X squared is just x squared minus 5. This would be my final answer. So hopefully this is making sense to you. I don't see any questions or comments over in the live chat, so we're going to go ahead and bring this video to an early end. Let me know if you do have any questions or things you'd like me to review or go over a little more in depth. Feel free to email me and we can go from there. And until next time, take care.